Welcome back, everyone. In this lecture, we're going to quickly go over the solutions for the Objects and Data Structures assessment test. So first off, we had that first question which just asks you for a brief description of all the following object types and data structures. We're going to go through that first and then head over to the notebook. So numbers, pretty straightforward. There's basically two types of numerical information that we can store. Those are integers for whole numbers, and floating points are numbers of a decimal. Then we have strings, which are an ordered sequence of characters. Lists, which are an ordered sequence of objects, and lists are mutable, meaning you can change items that are in a list. Tuples, very similar to lists, except that they're immutable. They're still an ordered sequence of objects themselves. And then dictionaries, those are key value pairings, and remember those are unordered. So now let's hop over to the other questions in the notebook. Alright, here I am at the solutions lecture. Pretty straightforward stuff. We just went over the first question, which was just answering about the data types. Then we have numbers. So all we had to do for this one was write an equation that uses all the various arithmetic methods we just discussed. And your answer is probably different than mine, but all you had to do was use multiplication, division, exponents, addition, and subtraction to somehow get back to 100.25. So a lot of this is just practicing order of operations, and you can just work backwards from 100.25 to make up your equation. All right, so your answer is probably different than mine, but here's an example answer. Then we wanted you to answer these three questions without typing any code. So what's the value of this expression, and this one, and this one? This is just to make sure you understand order of operations. So in this one, this first one, we're going to add these together before multiplying. In this one, we're going to multiply these two together before adding 5. And in this one, we're going to multiply these together before adding 4. And then the next question, what is the type of the result of the expression 3 plus 1.5 plus 4? So the answer for that one is a floating point number, because once you introduce a floating point number into this equation, it doesn't matter how many integers there are there, we're going to get a floating point number. Now the question, what would you use to find a number's square root as well as its square? So to get a square root, you can just mathematically say something to the power of 0.5 is the square root of the number. Later on, we're going to introduce the math library that will allow you to actually import a math function for doing the square root automatically. But in this case, this is a way to use a clever trick with exponents to get the square root. Then for the square, well, you know that's just asterisk, asterisk, and then 2. Next up were the strings questions. So for this one, given the string hello, we wanted you to list out the index commands to grab the letter E. So in this case, if we just count over from 0, let's zoom in one more level so we can clearly see this here. So 0 is at H, that means E is at 1, so we just had to say S of 1 returns E. Then we wanted to reverse the string hello using slicing. So we showed you this trick, but basically it means go from the beginning all the way to the end in a step size of -1. So a nice little trick there that'll reverse the string. And the reason that it's working is because you're going backwards through the string because your step size is a -1. Then we wanted you to give two methods of producing the letter O. So the ways to do that is using S to the negative, or S indexing at -1 to grab the very last letter of that string, or just counting from the beginning up to index 4. So those are two different ways of doing that. Then we had lists, and for this one we wanted you to build the list 0, 0, 0 in two separate ways. So the first way you probably did it is actually the second method listed here, which is just actually constructing the list using square brackets, pretty straightforward. But we also mentioned that you can use multiplication of a single list earlier in the course. So here we have this list 0 multiplied by 3, and now we see it here 3 times. Up next, we wanted you to reassign hello in this nested list to say goodbye instead. And the way you do that is you had to use indexing twice. So here we go 0, 1, 2 to grab the entire list. And then we go 0, 1, 2 to grab hello. And this is why we have 2, 2 reassigning to goodbye. And we get back the result here. After that, we wanted you to sort the list below. So there's different methods you could have done. One method that we showed you was this dot sort method, and then you just call the list again. But there's also a built-in function that I want to just introduce to you now, which is called sorted, and that allows you to pass in the list, and this one actually returns the list itself. So notice what's happening here. This dot sort method does it in place, meaning you need to call the list again in order to see the results. The sorted function will actually not do this in place, but instead return the sorted version. So that's the difference between using sorted and calling dot sort. Moving along, let's talk about dictionaries. So using keys and indexing, grab hello from the following dictionaries. And this starts off simple, but then gets harder and harder. First one, pretty straightforward. You just pass in simple key to get hello. And then the second one, you have two key calls here. So first you do K1, and that brings back this dictionary, and then to get hello from this dictionary, you just say K2. Then this one's getting a little trickier. So first we have to call K1, which brings us back this entire list right here. Then we have to call 0 on that list, because notice, and this is kind of the really tricky part, is that this is a list of one element. So in order to grab that dictionary, you had to call 0 there. So that one's really tough. And then the next one is nest key. So from there, you're just kind of dealing with a normal dictionary. And then you have that list coming out. So we want to grab the second item in that list. And a lot of people get tripped up by this last one. Why is there a 0 there? And that's because, just like before, we have a list of one element there. So if we just want to grab that one string element, we can say 0 and then get back hello. And then finally, the really tough one, which was, this is hard and annoying. So this one's a little crazy. And again, don't worry about real life code. Hopefully you never have to deal something with that. And if you do, this is really bad programming, but it's a pretty good question for practice. So what we do here is we say, grab the first key, then grab the second item from the list that returns, then grab K2 from that dictionary in here, grab at index 1, this dictionary right here, then we say grab tough, and then we just do some more indexing to finally grab hello. And again, there's a 0 at the end because this is a single item in a list. And what's really useful for you, if you need to kind of break this down and understand it, is just build it out step by step in some cells. So first run this, just d of k1, then run the next step, dk1 with 2, then run the next step, dk1 with 2 of k2, and so on until you get the result. Then can you sort a dictionary? Why or why not? The answer is definitely no, you cannot sort a dictionary because normal dictionaries are mappings and they're not a sequence. And if you're a beginner and you're dealing with really small dictionaries, this definitely isn't clear at first, but I can't stress enough that normal dictionaries are mappings and not a sequence, and they cannot be ordered. Later on, we're going to learn about some special libraries that do allow us to use kind of a dictionary-like object, which is called an order dictionary. But right now, normal dictionaries, you cannot order them or sort them. Then we have tuples. What's the major difference between tuples and lists? Well, tuples, as we learned, are immutable. And how do you create a tuple? Just with parentheses, as shown here. What's unique about a set? The answer is that they don't allow for duplicate items. So kind of a hint there, just with the word unique. And then we wanted you to use a set to find the unique values of the list below. So here you have this list, and then you pass it in through the set, and now we get all the unique elements of that list. Finally, we have booleans, and we had a little table here for operators. This is a bonus section because basically the very next section of the course is going to discuss comparison operators and logical operators. So you can see here the operators we have. We're going to explain this in a lot more detail in the very next lecture, but you have a description here and then an example. A lot of these are pretty straightforward. This is checking for equality, inequality, greater than, less than, greater than or equal to, and then less than or equal to. So hopefully just by learning that little table there, you can see that 2 is greater than 3, that's false. Is 3 less than or equal to 2? Well, that's false as well. Is 3 equal to 2.0? That's definitely false. And this one's kind of interesting. Is 3.0 equal to 3? Well, that's actually true. So Python, in this case, doesn't actually care that this floating point, and this one was an integer. As long as they hold the same value, it says they're true there. And then finally, is 4 to the power of 0.5 not equal to 2? Well, remember, to the power of 0.5, that's the same as the square root. So 4, square root of 4 is 2, so 2 is equal to 2, meaning the question is 2 not equal to 2 returns false. And then a final question here, also a bonus, what's the Boolean output of the cell block below? Well, let's take a look at it. L1, 2 of 0. So where's that? We have L1 at index 2, 0, 1, 2, we have another list, and then we want 0, so that's 3. So we know L1 right here at these indexings is actually asking for the number 3. So is number 3 greater than or equal to whatever this is? So let's take a look at that. We want 0, 1, 2, so 0, 1, 2 at key 1, so that's 4. So it's asking, is 3 greater than or equal to 4? And we know that's false. So that's the final bonus question. Okay, definitely these questions are a little more open-ended. They're not quite as structured. Later on, we're going to see a lot more structured questions that kind of have more technical right and wrong answers, and you're going to be able to kind of more efficiently program your way through the future tests. Thanks, everyone, and I will see you at the next lecture where we discuss comparison operators and logical operators. We'll see you there.